Okay, it's working. It's on the Bearded Weatherman. You got to search for it. Okay, we'll be going live here in a minute. So, gonna check in on the tropics tonight. How's everybody doing out there? Bearded Weatherman. We'll be going live here in just very shortly. We're also streaming to YouTube tonight for the first time, so welcome to all the YouTube people out there. I'm the Bearded Weatherman. I don't shave for TV like most of the meteorologists see on TV. That's where the name comes from. I'm a former Navy meteorologist and work in the airline industry, doing meteorology, watching flights, checking, making sure they're safe, all that. So I'm going to be doing a check-in on the tropics and looking at some local weather there in Central Florida, where a lot of my supporters are located. But we are not a page that only caters to those in Florida, so we're looking to talk about weather all over the country right now. All right. Let's go ahead and go live. How's everybody doing? Welcome to the Bearded Weatherman. Once again, if you are new to the page, I am a former Navy meteorologist. I work in the airline industry. I watch the weather every day, forecasting, making sure your flights are safe, and routed around thunderstorms and all the different hazards that are associated with weather out there for aviation. So welcome to the page if you're new. If you're watching live, go ahead and leave a comment, leave a question. If you're watching later on tonight or tomorrow, go ahead and leave a comment, and I'll check in on those and get to those in short order. All right, we're going to be talking about the tropics tonight. We're going to be talking about the activity that's out there now. It's starting to, as the cliche goes on the Weather Channel, it's starting to heat up in the tropics. Starting to see more activity. So we're going to discuss all that. Again, if you're watching, just go ahead and leave a comment and let me know how it's going out there. And if you have any questions or want to talk about a specific thing, go ahead and leave a comment, and I will get to those as soon as I can. All right, let's go ahead and check in on the big picture. This is what I always do. This is what meteorologists do when they come in to sit down for work. They check in on the big picture, see how weather is affecting one area and how it would affect another in a given time frame. I do a 10-hour shift at work, and then most meteorologists we did 12-hour shifts there in the Navy. I worked at the Maritime Forecast Center in Norfolk, Virginia. We covered a pretty large swath of the planet, watching operations and ships at sea, bases all around, all the way from Corpus Christi over here, Naval Air Station Corpus Christi in Texas, all of the Atlantic, North Atlantic, tropical Atlantic, Europe over here, all the way into the Mediterranean, or the Med as we say in the Navy. I gathered a lot of experience, gained a lot of experience in different climate regions. The U.S. weather, tropical weather like tropical storms, hurricanes, tropical cyclones, down into up into the North Atlantic, and the systems that would affect ships up there. We would route the ships around there. to make sure they were safe, and also we would watch bases all over the Western Hemisphere and the weather that would impact those bases. So that's my resume. I usually give that when I'm starting something new, like I'm streaming on YouTube for the first time. So welcome to any YouTube followers out there, viewers, whatever you want to call them. All right, let's get to weather. So again, I talk about the big picture right up front, and we do see a few features out here. So you see these tropical waves, as they're called, coming off of Africa over here. This is what normally causes tropical systems to form, like hurricanes, once they reach the Atlantic, and sometimes affect the U.S., obviously, or the Caribbean. You see a wave out here. We see some activity potentially starting up out here. So there's a lot more going on than in the last month or so. It's starting to that activity's starting to ramp up. So we're going to check in on that. But you see our three tropical waves. You see a very large ridge in place over the most of the Atlantic over here, mainly centered on the Azores over here, which would be, pardon me, this is the Azores over there. So this is why it's called an Azores High. Just checking in my geography. You see this trough over here that's affecting the eastern U.S. and causing a lot of weather for those folks. So this is mainly what's going on in the big picture. Ridges generally are associated with high pressure, sinking air, meaning less activity, less weather. It also blocks anything underneath it from going further north, and will cause these waves to sort of ride underneath until they can find a weakness or a trough here, generally associated with low pressure, and these will cause these systems to sort of ride up here into the weakness in that trough. So that's the upper level features, as they're called, meteorology. And so that's what our big picture is right now, looking at the satellite. All right, so let's check in. So we see here, this is the map. This is a 7-day outlook from the National Hurricane Center, giving you a forecast for the next 7 days in the tropical Atlantic. You see here 3 areas that they're looking at. So definitely an increase in activity from what we've been seeing. And let's see, check in over here. Let's see. Yeah, okay. But in any case, this is what we're watching here as meteorologists. You see here this yellow X. That's this this area over here off of the west coast of Africa, and then you see this other area that we've been watching, now near 0% chance. Looks like it's not going to make it. It's not going to develop anything tropical. That's good news for the Caribbean. And then you see this other area here, just a low 10% chance of formation for that area offshore, which you can see over here. Kind of, it's not much activity to it. You see there's just a couple of thunderstorms. Not much organization to it. Again, not much organization to this system. Very ragged, being affected by dry air. We can take a look at that. This system here is, again, not too much confidence in the forecast for this. It's just too much upper level winds. We can look at that in a second, that are affecting this tropical. And here's the wave over here off of the west coast of Africa, very far, very far from the U.S. and we'll talk about that too. So that's our main features. So again, here it is showing you basically where these will move in the next 7 days, and you see not much chance for development on these 3 systems as we stand today. All right, so let's go ahead and look at let's see what we're going to talk about next. We'll go to the Euro model. We'll check in on our forecast models just to get a sense of what they're saying as far as the forecast, or what they're looking at. This is the Euro model, ECMWF, also known as the European Center for Medium Range Weather Forecasting, located in the UK. Very accurate model, really respected by meteorologists. You see here the features. So here's our low off of the coast of Africa. Here's you don't even see much to this. You don't even see a low stamped here. See how it's just a trough? That's called an open wave or a tropical wave. So not much organization to it. Tropical systems require organization around the core of the system, and you're not seeing that with this system. And then a little bit of troughing over here, which is what they're talking about with this other system. But again, another open wave, not a low pressure, a tropical system. I've talked about this a lot on the Facebook page, but again, we've got the YouTube page going now. Just to real quick give you a synopsis of that. So, drawing on my blackboard here, we've got, let's see, this up. We've got a low pressure, right? And with a tropical, what you need to see is organization around the core of the system. So closed circulation. Again, we have a counterclockwise flow here at the west or northern hemisphere, pardon me. Counterclockwise flow around the low. You need a closed circulation or a closed isobar around the core of that system. This is the name. Isobars, by the way, for all our new viewers, is the drinking game here on the Bearded Weatherman, and I'm going to take a swig of mineral water. Mineral water is a family show from the foothills of the Colorado Rockies. Very effervescent, very sudsy. And there we go. So we need a closed isobar around that low pressure system, around the core of the low, in order to get that organization that's required for a tropical system. Without getting into too much detail on the meteorology, this closed circulation allows for that spin that you need for a tropical system. And we don't see that currently with, let's get back over here to our satellite. You don't see, or pardon me, to our analysis. You don't only see a closed circulation around this low over here off Africa, this wave, but none of that is occurring with our other features. So you see the troughing that's in place over here around this other system the National Hurricane Center is talking about. Here's the little troughing there. See, it looks like a trough. It's upside down, but it's a U. It looks like a valley or a trough, right? And you don't see organization currently with those systems. If we go forward in time now, let's go over to tomorrow afternoon, Tuesday, July 25th. Well, that's today, sorry. That was for today. Let's keep going forward. Kind of see that troughing offshore here, a little bit of trough. See maybe some organization down here, but this is very far to the south. It wouldn't be any threat to the U.S. or anything, and it's not really, looking at the models, it's not showing much development. Too much wind shear. These are higher wind speed values here. Tropicals don't like wind shear. Wind shear is a higher winds in the upper levels. It pushes aside a tropical system. They don't like that. So that's what's going on. And then you don't even see the L over here anymore, right? It's not even in place. Just the trough, the open wave, or tropical wave as they're called. So not much going on so far with these systems as of tomorrow morning. Here we go. We're going into, let's see, make sure you get that. This is, by the way, this is from a page called the Tropical Tidbits. Tropical Tidbits, great resource for tropical meteorology. Highly encourage you to check it out. It's a website created by Levi Cohen, who is a very expert meteorologist in tropical meteorology, a graduate of Florida State University. Their meteorology program is outstanding. So, in any case, highly encourage you to check that page out. You see, there is a little bit of a closed circulation around this tropical wave going into tomorrow afternoon. This is Thursday, July 27th. Here it is, 21 Zulu. So Zulu time is Greenwich Mean Time, or the time it is in the UK, in Greenwich, England. During standard time, or daylight savings time, pardon me, we are 4 hours back on the East Coast, 5 Central Time, 6 Mountain Time, 7 on the West Coast, Pacific daylight savings time. So this is the time that's used by meteorologists in the aviation industry. We use Zulu. It's a standardized time, so we don't have to say, well, it's 8 p.m. local. Well, what time is it where I'm at on the West Coast? So we've standardized it. This is the military is the big reason why these are used for operations, global operations. We know there's a standard time we can set for things. But in any case, 4 hours back from 9 p.m. Obviously, it's 5 p.m. Eastern Daylight Time. So this is tomorrow afternoon. Keep going. See, it's still a little closed circulation, but look how open this is. There's not even a stamped low on here. Very unorganized. You don't even see this other system anymore. A little bit of troughing here, maybe meaning some thunderstorms, a little bit of wind, maybe rain, but this is not really anything substantial like you see these big low pressure systems up here. Lots of circulation. See all the closed isobars around it. Isobars, when they're tightly packed, they're called a pressure gradient. Pressure gradient is what causes winds. So you see the much stronger wind speeds up around these systems. These are northern Atlantic systems. It has nothing to do with the tropics. So these are not what we're seeing down here. So as of Thursday night, we don't see that. Here's 0Z midnight, which at 4 hours back there. You got 8 o'clock p.m. on Friday. Going forward, do see a little bit more organization with the system, kind of maintaining some strength to it. But the other systems, we don't see any evidence of any longer. So again, that's why the National Hurricane Center has such a low probability for formation. Here is Saturday morning going forward in time, July 29th. So now we're in the weekend. That's 8 a.m. Local there on the East Coast. And keep going forward. Oh, let me get the pin in place here. There we go, or the pointer. It's still, troughing here. We do, again, no closed circulation. Tropical wave for Saturday afternoon, 5 p.m. There's 21Z on the East Coast. A little bit of more organization for Sunday, overnight Sunday for this system. So it's maintaining some strength. We keep going forward. It looks like it starts to slide up out to sea. Good news for the East Coast, at least according to the Euro. Let's get this pin to the correct thickness. For next week, going into early next week, this is overnight Monday, safely sliding out to sea, at least according to the Euro so far. So no threat to the U.S. from any of these systems, at least according to the Euro. One model I tend to favor. So my forecast is going to be that these systems will not be a threat to the U.S. as of right now. And so that's good news for the East Coast. All right, let's talk about, and again, you see why there's a little bit greater chance for development for this other wave, 20%, which is still pretty low, because you saw that it maintained some organization on the global modeler. Rick checking in. Sorry, it's been a few minutes. Rick's checking in from DeBerry, Florida, so that's close to my hometown of DeLand, Volusia County. I see a few folks watching there on Facebook. If you want to leave a comment, go ahead and let me know how you're doing tonight, and if you got any questions, we're gonna do a real quick outlook for the tropical season, as we don't see much activity as of right now. It's definitely getting more interesting. Definitely seeing more activity than we've seen over the last month or so, but not much chance of development at this time for these systems. I'm going to show you why in just a minute. So welcome, Rick. Thanks for checking in. I think you've been following this page for a little while, so appreciate your support as always. If you want to send some stars on Facebook, you can always do that, or YouTube. You can also support the page through YouTube. So again, appreciate the support, guys. We really appreciate that over here. All right, so let's talk about an outlook for the rest of the season. So what do we see big picture? Well, let's look at this. All right, a couple of factors in place right now, okay? So let's look at our analysis. So we see here this big plume of red here, right? This is warmer than average sea surface temperatures or ocean temperatures. See the reds here meaning as far as an anomaly or difference, right, from average. The anomaly is greater than average, so it's warmer than average sea surface temperatures here in the equatorial Pacific. That's an El Nino, right, warmer than average, and that's what we're going into right now. And as far as a weather regime, this typically means less activity in the Atlantic, so that's pretty good news. But the problem is you see all these reds in here over the tropical Atlantic. That means warmer than average temperatures on the ocean surface, so the ocean temperatures are warmer than average, so that does tend to favor more activity. So those two things are acting in concert. You normally see less activity with an El Nino year, but you also have much warmer than average temperatures in the Atlantic for this year. We'll show you those ocean temperatures now. See, very warm. This is in Celsius. This is the science. We use Celsius, but 32 degrees Celsius is over 80 degrees Fahrenheit, even closer to 90 in some cases. So you see those pink, purple shades here over the Gulf of Mexico. You see all the reds all over the region of what's called the main development region in meteorology for tropical systems. You see definitely that warm ocean temperatures are in place, that rocket fuel, that fuel for a tropical system to develop and strengthen. However, that's not the full picture. There is another factor that's very important in this discussion, and that is called the Madden-Julian oscillation. This is an oscillation between the tropical Pacific and the Atlantic. Remember, in physics, for every action, there's an equal and opposite reaction. In thermodynamics, which is the study of the dynamics of temperature, how temperature relates to physics, and energy can be neither created nor destroyed. That's one of the principles of thermodynamics. So what that basically means is for every reaction, there's an equal and opposite reaction. If there's energy over here, there's got to be some type of reaction over here. And that's called teleconnections in meteorology. It's the study of how different climate zones interact with each other. And the tropical Pacific and tropical Atlantic do interact with each other. The El Nino interacts with our weather here in the U.S. It tends to favor more drought conditions and hotter conditions for the West, and wetter winters for the for the Southeast. So there's different impacts that these climate regimes have on our planetary weather. So I'm going to show you a model that's important for the Madden-Julian oscillation. This is a measurement of the anomaly of rising air versus sinking air. Obviously, with thunderstorms and weather, you need rising air, right? You need that air to rise, cool to its dew point, condense into clouds, precipitate out as rain, and form thunderstorms and things like that. So you need rising air to do that. With sinking air, it's the opposite, right? Air is sinking. It means that clouds can't form, and if clouds can't form, weather can't form, right? So this is a model that is a forecast of where those rising air currents are going to be, and where those sinking air currents are going to be. And you can see that this is the entire planet here, shown on this model. We're going to go forward in time here. So right now you see a lot of rising air for the Pacific, and that is indicated by these green shades here, or negative values. That indicates rising air, whereas these red values indicate sinking air. So you can see here we have a regime right now where it's mainly, this is just a forecast out for a week from now, August 1st, as you can see. But you see here that mainly over the Atlantic, the air is sinking, and over the Pacific, the air is rising. And in fact, you look at the National Hurricane Center page, and you'll notice that there are, let's go back here. You'll notice currently there's a typhoon way out there in the Pacific, right? Big typhoon, but no real weather in here in the Atlantic. So we see these areas. There's more activity. It's very warm water out there. These systems have fuel, but the air is generally sinking or subsiding in the Atlantic, which means that these tropical systems can't fire up. They can't get that energy they need to form, and so that's what's killing off any activity in the Atlantic. But let's go forward in time and see. Again, this is a forecast model, but generally these models are pretty good, these climatology models, because they're just looking at big picture trends, and it's easier for the supercomputers that crunch this data to take in a lot of data over a larger area because the resolution isn't as high. Whereas when you zoom in on like a specific area, like a lake or a city, much harder for the models to forecast the weather there. That's why we only give probabilities in meteorology, because we can't get that fine scale resolution right now, and probably not for a long time, to the extent that we could model the entire atmosphere. It's just so much complex information. You notice, I love Jurassic Park, when Ian Malcolm, the chaotician, this is what these models are based on, entropy or chaos theory, interactions between complex systems. He says, butterfly flaps its wings in China, and you get rain in Central Park instead of sunshine, weeks later. That's the type of the small scale interaction with a bigger picture interaction that is just impossible for models to really forecast. But when you have a bigger picture, and you're talking about interactions between two climate systems, like what again we call teleconnections in meteorology, that's what this model is forecasting. So you can say, okay, you don't know. All right, the model's not telling you there's going to be a hurricane on this day, but it is telling you that the conditions will be more favorable if the other conditions are in place, like you have a tropical wave, for example, in the right region, and you have those light upper level winds, which is what this model's showing you, areas where there's lighter upper level winds versus stronger upper level winds. These reds are bad, danger for tropical. There's stronger upper level winds, more sinking air, and again, same for the green areas is lighter upper level winds, and again, tropical systems need those lighter upper level winds to thrive and to strengthen. Anyway, all that aside, we look here through next week. You see the red areas and the green over the Western Hemisphere, most of the U.S. and the Atlantic. Go forward in time, see very strong rising air there in the Pacific, so very favorable conditions for tropicals there out to 2 weeks. That's August 8th. So here we are in the first, second week of August now. Go forward. Now look at this. Big change from that regime into a different regime for the Atlantic and for especially the tropical, or I should say the Eastern Pacific, or East Pac as we call it. So very favorable conditions there in the Eastern Pacific, and more favorable than we've seen there for the Caribbean and for the Gulf of Mexico. This is typically where we see more activity in the early season, and we're still early on. I mean, most activity with tropical systems occurs in the let's get over here. I'll show you this chart. This page, by the way, is called Track the Tropics. Awesome page, kind of similar to other pages out there, like Mike's weather page, where it just brings together all kinds of products, as we call them in meteorology, and a lot of data, and just kind of collates it and puts it in one place for you, to one-stop shop for you as far as this goes. And I could go all the way down here to climatology. So here is July. Again, you see what I just said. Let me zoom in on that a little bit for you folks on your iPhones or whatever. You see the main areas for activity are going to be there in the Caribbean and the Gulf. Much warmer. It's much easier to heat those ocean basins. There's not as much mixing going on, and so therefore they can heat up a lot quicker than the Atlantic can. And so this time of year is generally where you see that activity. So you go forward in time into August, start to see that there's more areas where activity can occur, but you still see mainly it's over here towards the U.S., towards the Caribbean especially. You see most likely areas for development there in the Caribbean, here in the Gulf as well. So again, that's where you start to see the rising air currents favor more activity. This is for mid-August. So you start to look for mid-August, if you're talking long-range forecasting, as a possibility for that activity to start to fire up again. Those systems will have more of an opportunity to strengthen in this particular type of regime. Again, you start to see now this Madden-Julian oscillation migrates eastward, as you can see. Notice how it's starting to move eastward as we go forward in time. Here's August 22nd. That's a month out, right? Those greens more in place over the main development region in the Atlantic, where we normally see these tropicals form. And again, very strong updrafts and rising air currents, lighter upper level winds for the Eastern Pacific. So the Eastern Pacific's probably really going to see a ramp up in activity going into the end of August. And the Atlantic, again, even there's a very favorable conditions, at least according to this long-range model, going into that time of year. And then it starts to migrate off by early September. You see conditions are favorable more out in the Atlantic. And this is normal for the end of August, early September, when we start to see the most activity develop. I can show you that here. This great chart I've shown on my Facebook page 1,000 times, but I love it because it plots out the number of storms per 100 years. So this is the frequency of storms over a particular given period of 100 years. And here is the time of year that you plotted on the x-axis there at the top. And you see by far most of that activity is around September 10th or early September. You see this huge spike here in hurricanes and tropical storms, right? I'm going to get my red pen here. It's kind of hard to see. But you see the most hurricanes and tropical storms, and hurricanes, there's hurricanes in the yellow, there's the red, in the Atlantic at that time of year. And again, this is a study over 100 years and how many storms occur that, or how many storms have occurred over that 100-year time frame at that time of year. So again, normal to see more activity by then. The oceans have heated up. Takes a lot longer for oceans to heat up. It's called specific heating in physics. Takes a lot longer for water to boil, right, than it does for that pot to heat up. You put your finger on the pot right after you turn on the stove. It's going to be a lot hotter than that water. You can dip your finger in the water when you turn on the heat versus when the metal on that pan or pot, which has a much lower specific heating. And versus the oceans and water take much longer to heat, so it takes the entire summer for those things to cook and to start to really heat up, and then that's when we see most activity. Okay, real quick, I'll check in on local weather there in Central Florida. You don't see much activity. Those sea breeze storms have died off. See some showers there on the east coast of Florida, but no real thunderstorms like you see down here at the bottom. Let's see if you can see that right there. A couple thunderstorms down there southwest of Okeechobee, but most of the activity has now died off. The sun has gone down, and all the heating has died off, so those thunderstorms don't heat up and shoot up into the atmosphere and convection. And something real cool I'll show you real quick. This is some graphics I pulled to just show you what's going on with sea breeze thunderstorms, which is the main thing that happens in the summer in Florida. Anybody that's a Floridian knows about 3-4 o'clock in the afternoon we start to see thunderstorms. It's a daily thing in the summer. What you see here, what's occurring, you see a sea breeze sets up off of the Atlantic or the Gulf. This then meets with winds from the opposite side of the peninsula, right, coming from the Gulf or the Atlantic, depending on where you're at. That heated air rises, it flattens out at the top of the troposphere, and where the stratosphere is, a very stable layer of air up here that prevents further air rising, and then those storms start to precipitate out and form downdrafts, and they weaken. But this is what's happening over a period of the day as all that air is heated up and rises, and that's our sea breeze thunderstorms that we all know so well there in Florida. Currently, I'm located in Utah. I work for an airline out here, but I am a Central Florida resident. I just noticed that the light died off. I forgot to turn on the ceiling light. Anyway, it probably looks like it's like after dark there in background. Anyway, that's going to be it for today. Again, appreciate all the